All right, everybody, let's watch me do some work. All right, guys, so we need to now turn the machine on to the method parameters or the method settings. So we just walked through how to choose a method in the instrument, and this one's called the BAC analysis that we have saved, which is all of the temperature settings, the flow rates, and everything else that is needed in the instrument, so that way it knows how to run all of these samples. So how long do we run them for? How hot do we run them for? How long does it stay in the oven before we take it out, and so forth. So what we're going to do now is actually establish and download those method settings parameters. So we've already established the connection to the machine, but the machine still doesn't know what to do. So what we'll do is that over here, after we load the method, so we go up here to File, and we go to Open Method and choose the correct one, all of the information is dumped into the software. And up in here is where we talked about some of those quick check settings that we can just take a look at to make sure that everything seems reasonable. All right, so there is the quick check. Everything looks good. I went through the tabs, and we went through those tabs together to take a look at the auto sampler setting. We took a look at the split setting. We took a look at the column setting. We also took a look at the FID or the detector setting. So now we have to download all of this information into the instrument and turn the instrument actually on. So the way that we do that is over here to the left, over there is a button that says System On. So I'm going to click System On, and it says, do you want to download these instrument parameters? And I'm going to say yes, that's what I want to do. So now I hear the fans on, I hear my machine humming, that's a good thing. And now it's just kind of a waiting game in order to figure out, how long is it going to take for my oven to preheat before I put the cake in. That's kind of what we're doing. So the machine has to come to temperature, the flow rates have to stabilize, the air has to be generated, it has to be sent to the detector. And from this moment, I'm just waiting for green lights. Up here in the top left, I'll see the GC's not ready, but my auto sampler is, and then I also see that same information right here on the computer screen. GC says not ready, but the AOC says, yep, I'm good to go. So it's just waiting now, and then when these go green, we'll be able to run some samples and see how this is going to perform. All right, so there's a quick video overview of all of the still images that I showed you in the previous video. Again, the point of this is just to get you familiar with the software, where things are located, and the reasoning behind all of these steps that we have to go through in order to actually get samples and get them analyzed. It's not pretty. No one says it's easy, but no one said it was hard either. It's just aggravating, and it's a little time consuming is what this is. All right, so in that video, I kind of told you that over to the side, you are going to see a System On button. And that's the one that I chose. And then it said, do you want to download the parameters of the method that you loaded up? And I hit yes. So the reason that I did this is because our instrument was off, meaning that it wasn't running, it wasn't heating up, it had not previously completed samples at all. We just simply turned the power buttons on. That's all that we did. And we connected it to the machine. So because of that, this machine was not actually running in any form or capacity at this moment. So by hitting System On, then I told the software, download these parameters, send them to the machine, get the machine actually on and heating and flowing finally, because up until that point that had not been done. We had double checked regulators, we had double checked gauges, we had made sure that the supply was there when needed, and now is that moment of need. So that machine is now starting to eat all of the gas flows that are incoming through all of those regulator valves. And it's beginning to heat up, and it's beginning to kind of do what it needs to do, and it's getting ready for us so that way we can inject samples. Now, if the machine was already on And if it was already heating and if it was already established and we just got done with a little batch of samples and we needed to do some more, then what we can do is this button right up above, and it says download parameters. So we can simply hit download parameter, and it will send those new changes over to the instrument so it can begin to heat or cool down, or it can begin to slow the flows or increase the flows. It can do what it needs to do. But that's really for machines that are already established to the computer and the software. And at this point, again, we just turned some on buttons on. We turned on the software. We heard a beep, and it was like, yeah, they can communicate when needed, but that establishment is there. And now by hitting system on, we are establishing that connection, and they are talking to each other finally. And it's also killing two birds with one stone, and it's also sending method parameters over there as well. All right. So a little bit of quick check in the top right hand corner. I said, a lot of people just don't take the time to go through all the tabs and double check everything. Sometimes they just want a quick visual of how long is it going to take for this machine to get ready. And that's what this block is. And that was located in the top right hand side of the screen. A couple of what I would call necessities that are here. These are temperatures and flows that have to meet before this instrument can run and before it goes to a green light of ready. Up here on the top it says SPL1 temperature and pressure. SPL1, that is some of the injector settings that we made. The total flow and the purge flow, those are some of the column settings that we made while we were in there, or the injector settings. And then down here is the column settings for the temperatures and the heats. And then finally here at the very bottom are the FID, or the detector settings. So it has taken the most important pieces out of our method, and it has displayed them here on the computer screen. So that way we can do a quick view of flow rates and temperatures mainly to see how long it's going to take for this instrument to go green light. The reason that it shows those often take the longest. So getting the flows regulated and getting the temperatures heated and controlled will often be the most kind of the longest part of the wait up or the startup time that the machine will experience. Okay. So again, here's the overview. This is what we just talked about. And honestly, I think that you probably got a little bit more information from these sets of videos than you did if you were in person. Because if you were in person, it would have been in a classroom. And very often there's a group of people that stand behind me and that stare and breathe weirdly, like over my shoulder, and I hate it. And then we try to put big display TV screens in the lab area as well, so that way you can see that a little bit better. That has helped, but at the same time, I think that now you have watched these videos, you've not been distracted. I hope you kind of watched each step along the way and got up close and personal with all of the software issues that we have to go through here. The main working toolbar is here to the left. That is where the system on is at. That's where the download parameters are at. Up here at the top, that was our file button, and we did file open method, so that way it would download those temperature and flow rates. Here we see a not ready status, which is pretty normal. I kind of imagine that would be the case. We just now started it up. Here were all of the tabs that we went into to make instrumentation settings or changes to take place, and it's also where we went in and confirmed those temperature readouts and those flow rate readouts and stuff when we opened the method up. And then here in the top right hand corner, that is our short cut screen. So that is just a quick check of where things are standing at this moment. And again, we want everything to go green. The other thing I'm looking for is for stuff to go flat. So that basically means there's a signal that's on the computer screen, and that signal begins when we establish that communication. And from that point on, we will see a line that gets generated, and that line that is generated will hopefully be a very flat, stable baseline. So that's what we call this. It is a baseline. If that baseline is kind of doing this number, then that means there's contamination in our machine or in our gas or in our columns or somewhere within the innards of the instrument in some form or fashion. And we don't want to see that at all. So we allow this machine to kind of hum. That's what it sounds like. So we let it hum for a handful of minutes, 15, 20, 30 minutes before we do anything. And I'm going back and I'm looking at that baseline to make sure that looks pretty clean and pretty level and pretty straight. And it does. So I'm very happy with what I see there. All right, guys, we need to go through the process of entering samples. Now that machine is warm and the helium is flowing and the detector is lit, hydrogen's getting generated, everything's ready. So I need to go through the process of telling the software how many samples I have, what they are, let's name them, and let's run them one after another, after another, after another, without me being here in front of the machine. So the way that we do this, up here in the top left-hand corner, you're going to see a button that says main, and then you'll see a tab that says acquisition. So we are under the acquisition tab. Notice if I hit main, it changes the toolbar there, right? And then these options are system configuration, which is making my machine kind of figuring out what it has and what it doesn't have. Data acquisition is where we just were. We want to acquire data. We want to run samples and get numbers. So data acquisition is where we are. If I click that, my toolbar changes, and also it falls under acquisition now. So the way that we enter in more than one sample, if we had one sample, I would do start single run, and I would go in and I would enter in that information for that one container, but we have a bunch. So down here it says real-time batch. So I'm going to click the real-time batch, and my screen actually changes up on me now. All right. So there's a couple of columns that we need to go through and talk about what these mean. The first one is the tray name, and all of this information is in there from the prior run. So ours is going to change, of course. We're going to have to update it together. So under tray name, it all says 4. Now, the reason that it says 4 is because we've got multiple trays on the GC system. Right now there are 4. There could be more, there could be less, but right now we have 4 installed, and we've told the machine what those 4 are. Tray number 4 is all headspace. That's the main one that we're going to be using, and it is denoted in spot 4 on the machine. You've seen that in a picture. And then the other trays are for other things. Maybe not as many samples, maybe liquid injection, but not the headspace vials that we have that we need a bunch of. All right, vial number, it says 1, 2, 3, 4, 5, all the way down to 16. These normally go in order, and that's okay. They're supposed to. They don't have to, though. I can run them crazy-fied. I can put them in spot 4 and then run spot 48, then run spot 3, then run spot 16, then run spot 28, then go back to spot 1. I mean, it doesn't really matter how I run them, but most of the time people will fill this column in basically in numerical order as they load them up, and that's kind of the normal run-of-the-mill thing. All right. Next up is the sample name column. This is the sample name column. So we're going to go through here and we're going to name these samples, or we're going to name these standards. You just type it over. So for instance, I'm going to put blank, and I'm going to put 01 in for blank 01. And let me see if I can zoom in maybe a little bit closer for you. All right, there we go. So blank 01, and then after that, in spot number 2, I'm actually going to put another blank. I'm going to put blank 02 there. And then I'm going to run my standards, so I can name it standard 1A and then standard 1B. So STD 1A and then STD 1B, because remember, we ran these in duplicate. I prepared 2s of each one. And then after that, I can continue that trend. STD 2A and then STD 2B. And I'm just going to continue to fill this table out off screen so I don't waste any more of your time. The sample ID is the next column that's right here. Right now, everything is labeled as TH. This would be a great thing for a barcode or some type of unique identifier number. We never really use them. That whole column can actually be blank. It doesn't need anything to run stuff. By default, it's putting my initials, TH. I don't know why, but maybe I'm the one that uses it the most and it just knows me. It's kind of creepy. Next up is sample type. And I'm going to run everything as an unknown. And the reason we're running everything as an unknown is because I want you to do the calibration curve work on this set of data. If I click this box and I click the arrow that's right here to the right hand side that appears, you're going to see a prompt screen that shows up. And the prompt screen looks like this. A couple of things with the prompt screen. The very first option says unknown, and that's what we run everything as. The next one, if you notice, it says standard. So this is my way to tell the machine, these are actually standards. I want you to build the calibration curve. I want you to solve for all the math work. I want you to do all the Excel kind of work. I'm not going to be bothered with it. We don't like to do that in a program because sometimes it's much more complicated than what it needs to be. And for us, we're just trying to get a point across. And we like for you to go through the motions of doing a calibration curve on your own anyway. Next up is control and spiked and unspiked and standard for internal standards. And then finally an unknown for a QA/QC. All of those would be used in a real laboratory setting, but not here. We like to run everything as unknowns, process our own data in Excel, do our own regression lines, do our own calibration curves, solve for X, and so forth. So, hate it for you. All right, up next is the method file. And the method file is basically the instrumentation parameters that we need to run. Right now, if I click this box and I click the arrow that's beside of that, it's going to lead me into the CTC 210 forensics folder. And then under that forensics folder, we don't do too much with headspace in that course or in this class. And you're seeing BAC analysis that's there. I would double click that. It's already been double clicked. I can go through the motions and do it again if I want. Not a big deal. So I'll double click it. The DP is just us playing around, seeing what else is there. All right, so when I double click that, it updates it into the Excel cell. And now I'm ready to go to the next line. The next line is highlighted in yellow. That's the data file. It's going to automatically file name it. I don't have to do anything with that. The next one is level number. And level number would be my standards that I have prepared. So my standard 1, my standard 2, my standard 3, my standard 4. This way it knows this is the lowest concentration. It's going to plot that in a cal curve. But everything is here 0 because we're not using standards. We are running everything as an unknown. The injection volume is the next column. The injection volume is 1,000. So this 1,000 represents microliters. So we are injecting 1 milliliter of headspace or 1 milliliter of air that gets basically shot into the machine. Next is the multiple injection. We do not do multiple injections here. It's 1 shot only per container. That is it. Next is report output. So these are all checked off. I'm going to go through and uncheck those because I don't want this to print off as it runs. I want to do this after the fact all at one time. I want to look at the data first before I start wasting paper. So we'll simply uncheck them. To uncheck them, you just go through, click the box, and make it blank. We do that after the fact. Next is the report file. We have set a default report that we like to see on these lab activities. If I don't want that report, but a different type of report showing different types of data, I click the arrow box. and a pop-up occurs. And I'll just go through and select the report that I think is better for me. However, default is what we use most of the time. All right, so if I go back through and we just take a look at these columns again, when I enter in this information, I'm going to make sure my tray name is all 4. I'm going to number my vials where I put my containers, 1, 2, 3, 4, 5, however many it takes. I'm going to name my samples, blank 1, blank 2, some standards, and probably another blank, and then some samples, and probably another blank or 2 at the end. Next is the sample ID. Don't really need anything there. I can delete it if I want, but I'll just leave the default. Sample type is unknown. Everything we process manually. The method file all says BAC analysis. The data file will save it on its own. Level are zeros all the way down because we are running everything just straight up. Just give me numbers. I'll do Excel and math work a little bit later. Injection volume is 1 milliliter or 1,000 microliters. 1 injection per container. We do not want the report to be printed off. We do that after the fact. And then finally, the report format file is all default because that's everything that we need. All right, so now my GC and my auto sampler says ready, and we are ready to load these up, get them in the batch table, and hit start. All right, so in the next video, I'll just kind of go through, show you how I named them, and then we'll go from there.